Have you ever looked up at the night sky and wondered, is this really all there is? For thousands of years, humans have stared into the stars, searching not just for meaning, but for mirrors. What if, when a quantum decision is made, when a particle chooses between possibilities, the universe itself splits? Not just an outcome, one where you hit the brakes just in time, one where you didn't, one where Earth was swallowed by a black hole in its infancy, one where it never existed. Welcome to the many worlds interpretation, a radical idea that at first was ridiculed, ignored, forgotten, but it refused to die, because even if it sounds like science fiction, the math didn't rule it out. And that's what makes this topic so dangerous, so magnetic. It lives at the boundary between what we know and what we fear might be true. Even in popular culture, the multiverse has exploded. From Marvel to everything everywhere all at once, from Stranger Things to Interstellar, we're obsessed with the idea. But is that because science supports it, or because we want it to be real? Ask yourself, would you want to meet another version of you? But reality itself, branching like a tree, endlessly, into parallel versions of itself. Other worlds, other realities, versions of ourselves that made different choices. Universes where history took another turn. But where did this idea come from? And why does it grip us so deeply? Welcome to the question behind the question. This is not just about science. It's about the human condition, our restlessness, our dreams, and our desperate desire to believe. The concept of parallel universes taps into the deepest wells of imagination and regret, science and spirituality, fear and wonder. But in this series, we're going to go deeper than fiction. We're going to explore the cutting-edge physics, the ancient philosophies, the mind-bending paradoxes, and the haunting implications. Is the multiverse a fantasy of desperate minds? Or is it our future? In the chapters to come, we'll travel from quantum theory to cosmic inflation, from black holes to string theory, and from near-death experiences to AI simulations. But it all starts here, with a question as old as humanity. What if this isn't the only world? Stay with us, because what comes next will blow your mind. That something else is out there. Let's go back, not to Einstein, not even to the early quantum physicists. Let's rewind all the way to ancient times. Long before telescopes or particle accelerators, ancient cultures whispered of other realms. The Hindus spoke of endless cycles of birth and death across multiple dimensions, realities layered atop one another like the pages of a book. The Greeks told myths of shadow worlds, the underworld, Olympus, realms beyond mortal perception. The Norse imagined Yggdrasil, the great world tree, whose branches connected 9 parallel realms. Even then, before the word universe had ever been coined, humanity instinctively sensed there might be more. But why? Psychologists argue it's because we're meaning-making machines. We see patterns where none exist. We imagine possibilities to escape regret. What if I'd gone left instead of right? What if she'd said yes? What if I'd never left home? That emotional longing, what if, isn't just a daydream. It's the seed of the multiverse. Fast forward to the 20th century. Physics takes a sharp turn. Einstein rewrites our understanding of space and time with his theory of relativity. Suddenly, the universe isn't just a vast stage. It's alive, dynamic, and curved. But then something stranger emerges. In the 1920s, quantum mechanics cracks open reality at the smallest scales. And what scientists find inside makes no sense. Particles exist in multiple states at once. A single electron isn't just here or there, it's both, until you observe it. The famous thought experiment of Schrödinger's cat, a cat that is both alive and dead, became more than just metaphor. It became a clue, a paradox. Physicists were forced to ask, if particles can exist in superposition, what does that say about the universe? Then, in the 1950s, a young physicist named Hugh Everett asked the question no one dared to. Not just a particle, one where the cat lived, one where it died. The one who made the right choice? Or the one who made a mistake you never recovered from? Now that we've opened the door to the idea of parallel universes, it's time to ask the most unsettling question of all. What does science actually say? Is there any evidence, or even theory, that supports the idea that other universes might exist? A place where the rules of reality, as we understand them, begin to fall apart. Here, particles don't behave like tiny billiard balls. They behave more like waves of possibility, shadows of all the things they could be, flickering in and out of existence. The answer lies in one of the most mysterious and misunderstood realms of modern physics, quantum mechanics. But in the quantum world, until you look, the coin isn't just spinning, it's in a superposition. It's both heads and tails at the same time. One version of you sees it go through the left slit. Another sees it go through the right. The universe didn't change the electron's behavior, it changed you. Only when you observe it does it collapse into one state. Why? Because, oddly, it solves a lot of problems in quantum theory. No mysterious collapse. No need for an observer to affect reality. Just branching, clean, infinite branching. Let's begin at the smallest scale imaginable, far smaller than atoms. This is the quantum realm. Why can't we see them, touch them, detect them? Because the other branches don't interact with ours. They diverge, instantly and completely. Like ships passing in eternal fog. It predicts results with stunning accuracy. Without it, there'd be no computers, no lasers, no smartphones. It works. It's real. Imagine tossing a coin, heads or tails, one outcome or the other. And it turns out, the universe may have split, not just in the quantum past, but in the very first second after the Big Bang. We're about to enter a period known as cosmic inflation, and it might just be the key to proving that other universes do exist. That Occam's razor, the principle that says the simplest explanation is best, demands we reject the idea of countless invisible universes. Instead, every time a quantum decision is made, the universe splits. There could be infinite versions, or that the universe is expanding faster and faster, or that time slows down near massive objects. Reality, time and again, has proven to be stranger than fiction, each living in a slightly, or vastly, different universe. But this theory isn't just philosophical. It's supported by math. One version where it's heads, one where it's tails, one where the particle goes left, one where it goes right, one where you miss your train. It is the heart of that strangeness. But quantum theory is just one doorway. In the next chapter, we'll open another. When electrons are fired through two slits and no one's watching, they act like waves, interfering with themselves, creating a pattern that suggests they went through both slits. But if you measure them, just observe them, they behave like particles and go through only one. And meet your future partner, one where you never even get on. Let that sink in. According to this view, called the many worlds interpretation, every quantum event spawns a new universe. Not metaphorically, literally. Reality doesn't choose one path, it takes all of them. But what if that's not the full story? Hugh Everett, remember him? Had a different interpretation. He argued that the wave function, the mathematical formula that describes all those possibilities, never collapses. There isn't just one you. Take the famous double-slit experiment. Why? In the many worlds view, when you measure the electron, you split too. This sounds insane, right? But many physicists quietly support this interpretation. Of course, there are problems. If these other universes exist, where are they? And here lies the paradox. The very nature of the many worlds theory makes it nearly impossible to prove. And yet, despite this elusiveness, quantum mechanics itself is one of the most successful theories in the history of science. So if quantum mechanics points to a multiverse, should we take it seriously? There are scientists who argue, no, that this interpretation is extravagant, unfalsifiable. But others say, what if Occam's razor doesn't apply here? What if the universe is extravagant? After all, Who would have imagined black holes were real? And quantum mechanics? Because beyond the microscopic, there is the cosmic, the realm of the very large. Get ready. So far, we've explored the quantum realm, the bizarre micro-universe where particles flicker through multiple possibilities. But now let's zoom way out, to the largest scales imaginable, to the very beginning of time. Because there's another theory that points toward the existence of parallel universes. And this one doesn't begin with electrons, it begins with a bang. The Big Bang. According to our current understanding, the universe began roughly 13.8 billion years ago as an unimaginably hot, dense point. Then, boom, in a fraction of a second, it expanded explosively. Not slowly, not gradually, but with such incredible speed that space itself stretched faster than the speed of light. This phase is called cosmic inflation, and it changed everything. To understand why, imagine the universe as a rapidly expanding balloon. Except instead of blowing up a single balloon, cosmic inflation suggests there are countless balloons, each a separate bubble of space-time, each inflating in its own direction, each potentially becoming its own universe. This is where it gets mind-bending. The theory of eternal inflation, developed by physicist Alan Guth and others, proposes that inflation didn't stop everywhere at once. In some regions, inflation ended, creating a bubble universe like ours. But in other places, it kept going. Forever. New universes continued to bud off, like bubbles in a boiling pot. And they're still doing it. Right now, somewhere in the vastness beyond what we can ever observe. Each bubble, a universe, maybe like ours, maybe wildly different. One with different physical laws, one with no stars, one where gravity is stronger, one where life never evolved, or maybe one where everything is exactly the same, except you never clicked on this video. If that sounds like science fiction, consider this. Eternal inflation is a natural consequence of the equations we use to describe the early universe. It's not just a wild idea. It falls out of the math when we try to explain what happened just moments after the Big Bang. And here's the kicker. We might already have clues that it's real. Cosmologists studying the cosmic microwave background, the faint afterglow of the Big Bang, have noticed odd anomalies. Cold spots, asymmetries, tiny fluctuations that don't quite match predictions. Some scientists speculate that these irregularities could be bruises, evidence that our universe bumped into another bubble universe long ago. Let that image sink in. A ripple in the fabric of our cosmos, caused by a collision with another reality. Of course, the evidence isn't conclusive. These anomalies might have other explanations. But the idea persists because inflation itself is so widely accepted. And if inflation is real, then the multiverse might be inevitable. Think of the implications. Not just one Big Bang, but countless. Not just one set of physical laws, but an infinite variety. Universes born like sparks from a cosmic fire. And in each one, reality rewrites itself. Some scientists even suggest that this vast multiverse might explain why our universe seems so perfectly tuned for life. Why gravity, electromagnetism, and nuclear forces are balanced just right. It's called the anthropic principle. In short, maybe our universe isn't special because it's the only one. Maybe we're here because we live in the rare kind of universe where life is possible, and the others simply aren't. But again, a question echoes. If these other universes exist, why can't we reach them? Why can't we see past our cosmic horizon? The answer lies in the nature of inflation itself. These bubble universes are likely separated by vast stretches of still inflating space, expanding faster than light, forever keeping them out of reach. Like islands in an ocean that grows wider every second. We may never cross the waters, never glimpse the other shores, and yet the idea lingers, grows, expands. Because eternal inflation doesn't just suggest a multiverse, it requires it. So now we've seen two powerful theories, quantum mechanics and cosmic inflation, that both lead to the same radical conclusion: there may be more than one universe. Many, in fact, maybe even infinite. But we're not done yet. What if I told you the multiverse might not be out there at all? What if it's not a place in space, but a place in possibility? In the next chapter, we'll dive into string theory, a controversial but deeply elegant idea that suggests the universe is made not of particles, but of tiny vibrating strings. And those strings may be playing a cosmic symphony that echoes across dimensions. Get ready to enter the string realm, because the deeper we go, the stranger it gets. We've journeyed through quantum riddles and cosmic bubbles. We've glimpsed universes born from uncertainty and inflation. But now, let's zoom in again. This time, not to the quantum particle, but to something even smaller. Something that, if real, could be the foundation of everything. Welcome to string theory. At first glance, it sounds poetic, almost musical, and in a way, it is. According to string theory, the tiniest building blocks of the universe aren't particles, but tiny vibrating strings of energy. Each string, unimaginably small, about 100 billion times smaller than an atom, vibrates at a specific frequency. And here's the magic. The way it vibrates determines what it becomes. One vibration gives rise to an electron. Another creates a photon. Another, perhaps, a quark. Different tones, different particles, different notes, an entire symphony of existence. If this sounds fantastical, know this: string theory wasn't born from science fiction. It emerged from the desperate need to unify the two great theories of modern physics: quantum mechanics and general relativity. The laws of the small and the laws of the large. Because as brilliant as both are, they don't play nicely together. At the heart of a black hole or the birth of the universe, these theories clash violently. Infinite densities, undefined math, reality breaks down. But string theory, elegant, intricate, and maddeningly complex, offers a possible bridge. It proposes that gravity isn't a force acting across space, but a vibration, a song played by the strings. And here's where things get strange. Again, for string theory to work, for its equations to balance, and its beauty to hold, it requires something radical. More dimensions, not just 3 of space and 1 of time, but 10 or 11, maybe even more. Extra dimensions that we don't see or feel because they're curled up, hidden at microscopic scales, twisted in on themselves like tiny knots of reality. Imagine a garden hose. From far away, it looks like a one-dimensional line, but get close and you'll see its thickness, its circular cross-section. String theorists believe something similar might be true of our universe. We live in a 3-dimensional world, but hidden within it could be additional dimensions, just too small for us to detect. And within those dimensions, entire alternate realities may reside. In fact, string theory doesn't predict just one universe. It predicts a vast landscape of possible universes, different ways the strings can vibrate, different shapes the extra dimensions can take, each resulting in different laws of physics. In one, gravity might be stronger. In another, time might flow backwards. In another, atoms might not even exist. This isn't speculation, it's baked into the math. A nearly infinite number of possible universes. And here's the kicker. Some physicists now believe this landscape might be the multiverse. That our universe is just one valley in an unimaginably vast terrain of possibilities. We happen to live in this one. But others? They may exist too, separated not by distance, but by dimensional configuration. Like radio stations on different frequencies, all broadcasting at once, but only one coming through your speaker. Critics argue that string theory is untestable, that it's so malleable it can explain anything, and therefore nothing. And yet, it remains one of the most compelling ideas in theoretical physics, because it does what no other theory can. It offers a potential unification of everything, a theory of everything, and perhaps a theory of everywhere. But let's step back for a moment. So far, we've seen multiple roads leading to the same stunning idea that we might not be alone, not in space, but in reality itself. That this universe, with its familiar stars and particles and laws, is just one verse in a cosmic chorus. And yet we still haven't answered the question that haunts us. If there are other universes, can we ever reach them? Can we detect them? Send messages? Travel between them? Or are they forever beyond our grasp? In the next chapter, we'll descend into the heart of darkness, into the mystery of black holes. Because recent discoveries suggest that these cosmic monsters might hold more than crushed stars, they might be gateways. There is a place in the universe where the known laws of physics fall silent, where light cannot escape, where time slows and space collapses. This is not a science fiction story. This is a black hole. And for decades, these cosmic monsters were considered the dead ends of reality, regions where stars went to die. But in recent years, a new question has emerged. A question whispered in theoretical physics and echoed in the deepest corners of the universe. What if black holes aren't endings, but doors? Doors to other universes. To understand why, we have to confront what a black hole really is. Imagine a massive star, many times larger than our sun, burning through its fuel until it collapses under its own gravity. When this happens, it doesn't just implode, it compresses all of its mass into an infinitely small point. A singularity, a tear in the fabric of space and time. Around this singularity is the event horizon, the boundary beyond which nothing can return, not even light. To anything that crosses it, the universe outside simply vanishes. But here's where it gets strange. Einstein's equations. Yes, those same equations that predicted black holes in the first place don't say a black hole must be the end of space-time. They say it might be a bridge, a connection between 2 points in space, or 2 different universes. This hypothetical structure is known as a wormhole, a tunnel through the cosmic fabric. And while we've never observed one directly, the math suggests they're possible. Not just possible, inevitable under certain conditions. Some scientists believe that every black hole might be a one-way tunnel to a parallel universe. When matter is swallowed, it doesn't simply get destroyed, it gets recycled, reborn elsewhere, in another space, another time, another reality. But wait, wouldn't that violate the laws of physics? Not necessarily. Enter the concept of information. In physics, information means the quantum state of everything that falls into a black hole. What it was, where it was, how it moved. Stephen Hawking once argued that black holes destroy information. But this created a paradox. The laws of quantum mechanics say information must be conserved. It cannot be erased. Years later, Hawking revised his view. Maybe black holes don't destroy information, maybe they encode it. Store it in subtle ripples on their event horizons, or send it somewhere else entirely, like into another universe. And it gets weirder. Some modern theories, like those from string theory and quantum gravity, suggest that black holes might be connected to something called a white hole. A white hole is like the reverse of a black hole. Nothing can enter it, and everything comes out. Explosively. No one has ever seen one. But some believe that the Big Bang itself, our universe's birth, was a white hole. The end of another universe's black hole collapse. A cycle of creation and destruction. A cosmic recycling machine. What if that's how universes are born? What if each black hole in our universe births a new universe with slightly different laws of physics? A daughter universe. A child cosmos. Imagine, inside every black hole could be a new universe, complete with galaxies, stars, and perhaps even life. That means, right now, in the center of our galaxy, the supermassive black hole known as Sagittarius A** might be nurturing an entire alternate reality. A universe tucked within ours, invisible yet real. It's a staggering idea. But again, there's a problem. We can't go in and find out. Any spacecraft or signal that crosses the event horizon is lost to us. At least, according to our current understanding. But that doesn't stop the theories, because black holes keep surprising us. In 2019, we captured the first ever image of a black hole, a glowing ring of light surrounding a dark abyss 55 million light-years away. A glimpse into the unknowable, and yet it made the unknowable feel closer. Maybe, just maybe, the multiverse is closer than we think. Not out in the void, but hiding in the shadows of collapsed stars. Black holes might not be the prison cells of matter and light. They might be the gateways of gravity, the tunnels between worlds. So where do we go from here? We've looked outward, to quantum particles, cosmic expansion, vibrating strings, and the centers of galaxies. But what if the next clue is inward? Not in the stars, but in our minds. In the next chapter, we'll explore one of the most controversial and fascinating possibilities. Are parallel universes connected to consciousness? Is the multiverse not just a physical phenomenon, but a mental one? Could your mind itself be the bridge? We've soared through galaxies, peeked into quantum shadows, and dived into the hearts of black holes. But now let's pause. Let's turn the telescope inward. Because there's one piece of this puzzle we haven't examined closely. A phenomenon so familiar we barely question it, yet so mysterious it remains unsolved by science. Consciousness. What is it? Where does it come from? Why does anything, even a universe, need to be observed to be real? And perhaps the more disturbing question, does our consciousness play a role in which reality we end up in? Let's rewind to quantum mechanics. Remember the double-slit experiment? Particles fired at two slits behave like waves, until observed. Once measured, they behave like particles. It's almost as if the act of observation collapses the wave of possibilities into a single outcome. This led to one of the most debated ideas in modern physics, the observer effect, that somehow conscious observation can influence the state of reality. But hold on, are we really saying that a human mind can create reality? Not quite, but the implications are tantalizing. Some interpretations of quantum mechanics, like the Copenhagen interpretation, suggest that reality doesn't fully exist until it's measured, that it lives in a suspended state of probabilities until a conscious observer forces it to choose. This is the observer's paradox. Does reality need a mind to manifest? Or is the mind simply discovering a pre-existing world? Now let's stretch that even further. If every observation, every quantum decision, splits the universe into branches, what role does your observation play? Could your consciousness be the needle that stitches together your path through the multiverse? Each choice you make, each perception, each moment of attention, could it be a selection mechanism, filtering infinite realities into the one you currently experience? One version of you chose to watch this video. Another kept scrolling. Both exist in parallel. But you are here, watching this. That's the version you're living. Some theorists, particularly those dabbling in quantum consciousness, suggest that the mind is not just an emergent property of the brain. That consciousness itself may be quantum, a non-local, probabilistic field that interacts with the very fabric of reality. This is where science enters uncertain terrain. The orchestroir theory, developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, proposes that consciousness arises from quantum events inside the brain's microtubules, structures within neurons. If true, it could mean that your awareness is not entirely confined to this universe. It could mean that consciousness is entangled across possibilities, that it can drift between them. This theory is controversial. Many scientists dismiss it as speculative, lacking solid evidence. And they're not wrong. Measuring consciousness is like trying to bottle smoke. But what's undeniable is that consciousness remains one of the great unsolved mysteries of science. And the deeper we look into the multiverse, the more this mystery reappears. Take this idea even further, and we reach something called the participatory universe. Proposed by physicist John Archibald Wheeler, this concept suggests that observers are not separate from the universe, but essential to it. In other words, the universe is incomplete without you. Without a mind to witness it, reality has no meaning, no shape, no narrative, which begs the question, are we passengers in the multiverse? Or are we its co-creators? Are we dreaming reality into being one conscious decision at a time? It's a humbling and haunting idea. What if your thoughts don't just echo within your skull, but ripple through an infinite field of realities? What if the mind is not a product of the universe, but the canvas upon which the universe is painted? Even if we can't prove it, yet, the possibility forces us to reconsider the role of consciousness in cosmology. We are not just observers. We are participants. So, in this unfolding story of multiple universes, maybe it's not just space-time that defines our destiny, but awareness itself. The mind may be the most mysterious universe of all, but the mystery doesn't end here. Because as strange as quantum and cosmic theories are, some believe there's another possibility, one that doesn't come from the fabric of reality itself, but from human invention. What if the multiverse doesn't already exist, but is being created by us? What if everything you've ever seen, felt, or believed is part of a simulation? It sounds like a scene ripped straight from the Matrix, but the idea that we might be living in a digital construct, one carefully designed and programmed, has gained surprising traction among scientists, philosophers, and tech visionaries. This is simulation theory, and it raises one of the most unsettling questions of all. What if the multiverse isn't a natural phenomenon, but a technological one? Let's begin with the philosopher Nick Bostrom. In 2003, he published a now-famous paper proposing a logical trilemma. One of three things must be true. Human civilizations will never reach a point where they can run high-fidelity simulations of reality. Civilizations that do reach that level will have no interest in doing so. We're almost certainly living in a simulation right now. The same way a game engine is designed to support characters, landscapes, and rules, our universe might be optimized to support complex life, or consciousness, or curiosity. And maybe that's the point. Maybe the creators want to see how simulated beings evolve, how we love, how we struggle. We haven't found proof, but we're looking. Then there's quantum entanglement, particles separated by vast distances that still behave as if connected. Some scientists wonder, could this be a sign that space itself is not real, but simulated? There's no way to know for sure if you re at the bottom or somewhere in the middle. But what would be the purpose? Entertainment? Experimentation? Evolution? Or something far more profound? In the next chapter, we'll step back from technology and turn toward ancient traditions and mysterious human experiences. Because long before physics and programming, people spoke of visions, dreams, and journeys to other worlds. Are those stories symbolic? Or are they memories of something real? But if the simulation hypothesis is even partly true, it could mean that the multiverse doesn't exist out there in physical space, but inside digital space. A cosmic cloud of programmed realities. Some stable, some chaotic, some forgotten. That distant particles are being updated simultaneously by an underlying program? How we ask questions like, are we simulated? But is there any evidence? Or is this all just philosophical science fiction? Well, here's where things get weird. At first, it sounds absurd, but let's follow the logic. Some have claimed that the fabric of space-time might be pixelated, that there could be a smallest possible unit of distance, like the pixels in a screen. Others point to the strange mathematical beauty of physical laws, as if the universe runs on code. Even the equations that describe electrons and gravity are eerily elegant, almost engineered. Imagine a future civilization, one with computing power so advanced it can simulate an entire universe down to every atom, every particle, even every conscious being inside it. So might everything. And here's where it connects to the multiverse. If we're in a simulation, where's the proof? And even if we find it, what do we do with it? Would it change anything? Would you live your life differently, knowing your world was code? And what about the simulators? Who are they? Advanced humans? AI superintelligences? Or something beyond comprehension? Perhaps they're not observing us. Perhaps we are the experiment. And then comes the biggest question of all. If we are a simulation, could there be simulations within our simulation? If a post-human civilization can run one universe, why stop there? They could run many. Simulations with slightly different laws of physics, different initial conditions, Different outcomes. Universes where humans went extinct. Universes where dinosaurs evolved intelligence. Universes where you were never born. Sound familiar? It's the multiverse again, but born from code, not from nature. A civilization so far ahead that simulating history, or even alternate timelines, is as easy as rendering a video game. How many simulations would they run? Dozens? Millions? Infinite? Now consider this. If such simulations exist, and if each one contains self-aware entities, then the number of simulated conscious beings would vastly outnumber the real ones, which means the odds that we're the original base reality, statistically speaking, very, very low. You might be a simulation. So might I. Some theorists now propose that these simulated realities might explain why our universe appears so fine-tuned for life. In recent years, scientists have found some odd patterns in the structure of the universe. In 2017, a team of theoretical physicists at MIT suggested that certain high-energy cosmic rays might reveal glitches in the matrix, tiny inconsistencies in how space-time behaves. Of course, the skeptics fire back. Nested realities, universes within universes, each running on its own rules, each unaware of the one above. A multiverse of simulations. And the scariest part? And maybe, just maybe, you're watching this video from inside one of them. Long before the multiverse was a theory before quantum mechanics, cosmic inflation, or simulations, humanity already believed in other worlds. They didn't call them parallel universes. They called them the spirit realm, the dream time, the other world, the realm of the gods. Different names across cultures and continents. But the idea was always the same, that this world is not the only one, that behind the veil of reality, there lies another, or many, and perhaps, just perhaps, those ancient whispers were pointing to something real. Let's go back thousands of years. The Aboriginal peoples of Australia speak of the dream time, not merely a time in the past, but a layer of reality. A timeless dimension where ancestral spirits shaped the land and continue to exist, running parallel to our world. To them, the dream time is not a metaphor. It's a world that can be entered through rituals, trance, and dreams. Sound familiar? In Norse mythology, there are 9 realms connected by the great tree, Yggdrasil. Midgard, the realm of humans. Asgard of the gods. Helheim of the dead. Realms stacked not just vertically, but dimensionally. The Hindus speak of countless lokas, realms layered over and beneath this one. Some are physical, others are purely consciousness. The soul travels through them in cycles of death and rebirth. Even in Christian mysticism, there are heavens, hells, and hidden realms where angels and demons dwell. Realities adjacent to our own, sometimes crossing over in visions, miracles, or madness. These stories were not told for entertainment. They were maps, not of geography, but of experience. Inner journeys that hinted at outer truths. Could ancient humans have glimpsed something we've forgotten? Let's fast forward. In the modern era, strange experiences continue, though we now call them by different names. Near-death experiences, lucid dreams, DMT trips, alien abductions, out-of-body experiences. Different language, same theme. Crossing into a realm not our own. Encountering entities not from this world. Returning with visions, insights, or trauma. Are these hallucinations? Malfunctions of a dying brain? Or brief collisions between realities? Consider this. When people under the influence of DMT, a powerful psychedelic, are interviewed, they often report entering other realms that feel more real than this one. Realms filled with light, geometry, intelligence, a sense of familiarity and multiplicity. What's fascinating is how consistent these reports are. Across cultures, across time, across belief systems. Is it possible that certain states of consciousness unlock access to something else? Modern science has no firm answers, but there are theories. Some neuroscientists suggest that altered states may change the brain's filtering system, allowing a broader spectrum of reality to be perceived. Others speculate that the brain might act like a receiver, not a generator, of consciousness. That in certain moments, especially at death or during deep trance, it may tune into other frequencies, other realities. If so, these ancient visions may not be superstitions at all, but brief contacts with other dimensions, other universes. What if mythology isn't primitive science? What if it's encoded memory, a symbolic retelling of real multiversal contact? And what about dreams? Every night, we drift into worlds where time breaks down, where people long gone are alive, where places bend, morph, collapse, where laws of physics mean nothing. What if dreams aren't just mental noise? What if they're echoes of parallel versions of ourselves? Science may scoff, but even Einstein admitted that imagination is more important than knowledge. And quantum physics has taught us that reality is not as firm as it feels. So, we're left with a haunting possibility that from the earliest shamans to the latest psychonauts, humans have been reaching across dimensions, and sometimes something reaches back. And maybe, just maybe, our obsession with stories, myths, visions, dreams isn't just about escaping this world, it's about remembering the others. Because the multiverse might not be a cold expanse of probabilities. It might be a living mosaic, woven into the fabric of our minds, our stories, our symbols. And we've been walking through it all along. But now it's time to ask a darker question. If parallel universes do exist, if they're real, reachable, or even created, who or what controls them? And could there be rules to the multiverse that we haven't yet discovered? So far, we've imagined parallel universes as infinite, chaotic, and open-ended. A cosmic lottery where anything goes. Every choice, every timeline, every possibility playing out somewhere. But what if there are limits? What if the multiverse isn't a wild jungle of randomness, but a finely tuned machine, operating by laws we don't yet understand? Let's go back to quantum mechanics. At the heart of the many worlds interpretation lies a strange idea, that the universe branches with every quantum decision. A particle goes left, one universe. It goes right. Another. You go to work. You quit your job. Two timelines, two versions of you. But here's the twist. These branches aren't equal. Some are more probable than others. And the universe seems to favor order over chaos. This hints at something deeper, a kind of cosmic bias. Just like in evolution, where infinite mutations are possible, but only the fittest survive. Maybe universes follow a similar path. Not every world thrives. Not every reality lasts. Some physicists call this the anthropic principle, the idea that we live in a universe that supports life because only those kinds of universes are observable. In other words, we see this universe because it allows beings like us to see it. But what about the others? Could there be dead universes, ones that collapsed after a few seconds? Realities with no stars, no chemistry, no time? Are those universes still out there, or do they vanish when they fail? This brings us to a controversial idea, the multiversal selection theory. It suggests that, like life, universes may undergo natural selection. Only the most stable realities survive, the ones that obey certain cosmic laws. It's a theory without solid proof, but it forces us to ask, could there be rules, cosmic laws, governing how realities split, survive, or die? Let's go deeper. What if there are limits not just to which universes exist, but to how we interact with them? There are theories in string physics suggesting that different universes may exist on different branes, dimensional membranes that float in a higher dimensional space. These branes might collide, merge, or pass near each other, but they don't mix freely, like parallel train tracks, close but never touching. Unless there's a tunnel. Some theorists propose that wormholes, Einstein-Rosen bridges, could link one universe to another, but they would need unimaginable energy to remain stable. And even if they did, traversing them could violate the laws of causality, leading to paradoxes or collapses. In other words, there might be natural safeguards in place, built-in rules to prevent catastrophic crossover. But here's a darker idea. What if some entities or civilizations have found a way to break those rules? Science fiction, and even some fringe science, suggests that if we ever create an artificial universe, say, inside a supercomputer or advanced quantum machine, we might become creators of a new reality, a pocket universe. And then what's to stop our universe from being someone else's simulation? If so, then perhaps the rules of our universe are not natural laws, but coded boundaries. Restrictions imposed to prevent us from breaking out, or from discovering the truth. Are déjà vu, glitches in memory, or strange coincidences hints that our universe has seams, breakpoints where it almost intersects with another? Some argue we're already testing the boundaries through particle accelerators, quantum computing, and simulations of reality. Could we one day punch through? But here's the real question. If there are rules, who made them? Are they the product of fundamental physics? Or are they designed by a civilization unimaginably more advanced? What if, just as we create digital worlds for games or AI, higher beings have created ours and embedded laws to keep it running? Maybe the cosmic constants aren't constants, they're parameters. We used to think the Earth was the center of everything. Then we thought the sun was. Then the galaxy. Now we wonder if even our universe is just one tab open in a much larger system. A multiverse with its own logic, its own walls, and its own gods. But there's one final frontier we haven't crossed yet. If the multiverse is real, if rules exist, if intelligence can shape universes, then the last and most haunting question is, are we alone in it? And if not, what's out there watching? All throughout human history, we've told stories of mysterious beings, gods, spirits, angels, aliens, entities that appear suddenly, inexplicably, as if they've stepped in from another world. What if they have? What if those worlds aren't imaginary? What if they're real and they're closer than we think? Let's suspend disbelief just for a moment. We've followed the science, explored quantum interpretations, peeked into the string landscape, and danced on the edge of cosmic inflation. And all of it suggests one stunning possibility. There is more than one universe. And maybe, just maybe, they touch. So what happens when they do? There are reports, unexplained phenomena, déjà vu, people vanishing without a trace, dreams that feel more real than waking life, glitches in memory, objects appearing in the wrong place, events that cannot be explained by the physics we know. Are these just flukes of the mind? Or are they crossovers? Brief, unintended intersections between parallel timelines? Some physicists argue that such leaks would be statistically improbable, even impossible. But if universes can interact, even minutely, through quantum entanglement or shared origins, then information or even entities might find a way through. Let's go deeper. In quantum theory, there's something called quantum tunneling. A particle can disappear from one side of a barrier and instantly reappear on the other without ever crossing it. What if that's not limited to particles? What if consciousness or intelligent beings can tunnel? What if they already have? Here's where it gets strange. Throughout cultures, ancient Sumerian tablets, Mayan codices, Hindu epics, even modern UFO lore, there are eerily similar descriptions of entities descending from the skies, walking through walls, bending time, or delivering cryptic knowledge. Maybe they're not aliens in the traditional sense. Maybe they're interdimensional, travelers not from distant stars, but from adjacent realities. Could the visions of shamans, the hallucinations of mystics, the downloads claimed by some geniuses all be windows into other worlds? Could our brain, wired at the quantum level, sometimes receive signals not meant for this universe? Theories like panpsychism and consciousness as fields suggest that our awareness might extend beyond the physical, like an antenna picking up frequencies. What if some people are more tuned to parallel frequencies than others? Now imagine this, an intelligence far older than ours. Not biological, not bound by time, but aware, watching, studying, not with malice, but with the cold curiosity of a scientist observing an ant colony. Would they announce themselves? Or would they whisper, drop fragments of knowledge, influence evolution subtly, test our limits? Carl Sagan once warned, the universe is not required to be in perfect harmony with human ambition. But what if there are other intelligences whose ambitions dwarf our own? Here's a terrifying idea. What if some of the events we dismiss as random, the rise and fall of civilizations, bursts of genius, even mass extinction events, are nudges? What if we're part of an experiment? Or worse, what if we're entertainment? A cosmic simulation, watched across dimensions? Of course, many will say, this is wild speculation. And they're right. But every leap of science began as speculation. Galileo, Darwin, Einstein, they were all once accused of madness. Now, we don't claim to know for sure. The multiverse may remain forever hidden, an unreachable truth. Or we may find the key, through quantum computing, through dreams, through mathematics so advanced it feels like magic. But until then, we're left with the most humbling and haunting truth of all. We don't know what's out there. We don't know who, or what, might be watching. We don't even know if we are the prime reality or just one version among trillions. And that is both the terror and the beauty of existence. So when you look at the stars tonight, remember, you might not just be looking into the depths of space. You might be looking into the eyes of another universe staring right back.